So hello everyone, good afternoon. My name is Joshit and welcome to Gradeup, India's largest live learning platform. So guys, how are you all? Quickly please let me know, am I audible and visible to each one of you? Kindly please tell me. So hi, good evening. कैसे हैं आप? Aman. Hi Chandrlekha, good evening. How are you? So we are here to discuss the questions for irrigation engineering. And guys, if you are able to get 70% marks in this test, you're done with irrigation, right? You don't have to give extra attention to irrigation engineering, right? So I'm again telling you guys, if in this particular test, if you get more than 70% marks, then you don't need to revise irrigation anymore, right? Because I have covered, I think, the whole irrigation engineering in this particular test. Again, from 60 to 70%, if you are getting, or I think it should be now 75%, right? And 60 to 75% if you are getting, then you can just do it, give it a one quick revision, okay? It's fine. And guys, if you get less than 60% in this test, then guys, you have to give it a proper attention, right? So hi Vishnu, how are you? Good evening. Aman, I'm super fine, thank you so much for asking. Hi Ritu, good evening. कैसे हैं आप? So quickly guys, just share the video with any one friend of yours. Also just hit the like button if you are joining just now, and subscribe the channel if you are watching me for the first time on this channel. Okay, so we'll begin the session guys in just few seconds. Till then, please let me know guys, how are you all? क्या हाल है? Quickly please tell me, how are you all? Everything is going great? Okay, so guys, I'll quickly introduce myself to those who are watching me for the first time. My name is Joshit Singh and I have 3 years of teaching experience. I'm MTech from IIT Roorkee and GATE multiple times qualified. Area of expertise are transportation engineering, fluid mechanics, irrigation and environmental engineering. GATE mock test is completed for your highway engineering, for fluid mechanics, for environmental engineering. Today we are here to complete, this is the last session of your Gradeup GATE, you know, this mock test series of civil engineering, right? This is the last session and today we are going to discuss the questions from irrigation engineering, right? This is the schedule for Abhi or Josh series which is going on Gradeup Civil Champion YouTube channel. Today we have Minty War. How many of you are aware what is Minty War? Are you aware of this thing guys? What is Minty War? Hi Anusha, good evening. Ritu, I'm super fine, thank you so much for asking. Yes, I'm super fine. Vishnu, thank you. Hi Jayesh, good evening. Dost, kaise ho aap? If you are not aware of this Minty War, let me tell you guys that there you'll be in one team, like there will be only 2 teams. One will be Abhinav sir's team and second will be my team, right? Commandos versus ninjas will be there. So basically there you have to solve the questions from environmental engineering, fluid mechanics, and soil mechanics and your hydrology. These 4 subjects you have to prepare and the questions will be from these 4 subjects only in this Minty War. Okay, hi, good evening Simran, hi Varsha and Kaushik, good afternoon guys. I hope aap sab bahut achhe honge, right? So today 8 PM we have Minty War on Gradeup Civil Champion YouTube channel. You can join. Then after that, today we have this last session of this thing. The SOM is done, right? SOM is done for your mock gate test. Soil is done, FM is done, highway is done, hydrology is done, surveying is done, environmental is done, and now irrigation will be completed today, right? Minty War syllabus. Minty War syllabus is you are supposed to revise environment, fluid mechanics, soil and hydrology. These 4 subjects will be there in your today's quiz, all right, in your Minty War. It is requested to each one of you to join the quiz at the right time, because otherwise you won't be able to solve all the questions, right? Session will begin at exactly 8 PM. So join there. Prateek, good evening. How are you? So let's begin the session without any further delay. Guys, I have tried to cover each and every topic, okay? So kindly try and answer this question with full power. For each question, you will be getting 1 minute. 1 minute is just to understand that what should be the approach to solve this question. And later on, obviously, I'll tell you the solution. Then you can see if you could have got the answer or not. If you are getting 75% marks in this mock test, then guys, you can say that you are in a good position if I talk about irrigation engineering. If you get 60 to 75, it means you need to revise one more time irrigation engineering properly. And if you are getting less than 60%, then guys, you have to give proper attention to your irrigation engineering, right? Right, so let's begin without any further delay, guys. Full power ke saath. Please let me know the answer for this particular question. An irrigation canal is 50 kilometer long, has an average surface width of 20 meter. If the evaporation measured in a class A pan in 5 mm per day, the volume of water evaporated in a month of 30 days is dash. Pan coefficient is given as 0.7. Not at all tough question, so please try and answer. Hi Bhaskar, good evening, how are you? Okay, good. Rishabh, Varsha, Aman, Shooter Vlogs and Madhvi. Alright. Let's see, guys. Let's see who have got the first answer. Do you want me to make a box of fame also? Should we get a box of fame as well? Okay, so let's do one thing. Let's have a box of fame today also. And then we will see whose name was there for the maximum time in this particular box of fame, right? So today's the first name is Varsha. Right, because the answer is D. How D? You can see from here. So guys, basically you have to get the volume, right? So how much depth is evaporated into whatever the area we are having. Cool. So you can clearly see here we have 50 kilometer, right? 50 kilometer we have the length and the width is 20 meter, right? 50 and 20 meter. Other than that, this 5 mm per day is given to us. So 5 mm per day is given to us. Per day means how many days do we have? We have exactly, you can see from here, 30 days. So if you have 30 days, guys, okay, then what is the pan coefficient? 0.7, just 0.7. And what is the answer that you are getting from here? Let's see this. So the answer should be 10500 hectare meter, right? So D is the correct answer. Set hai? Let's move to the next question, guys, and let's see who will give me the first answer. This is a MSQ question. Everybody please try and get me the answer. This is the MSQ question. Kindly solve this question and get me the answer so that I can write your name in this box of fame with full power, everybody. The cultivable command area of Canal is 10,000 hectare. The area grows only 2 crops, rice in the Kharif season and wheat in the Rabi season. The design discharge of the canal is based on rice requirement, which has an irrigated area of 2500 hectare, base period of 150 days and delta of 130 centimeter. And for wheat, base period is 120 days and delta is 50 centimeter. Which of the following statement are correct? Design discharge is 2.5. Maximum permissible irrigated area of the wheat is 5185 hectare. Or design discharge. Come on, guys, full power reply. All right. Okay, let's see. Let's see who will give me the first answer, everyone. Okay. Brilliant. So, yep, the first answer was given by Chandralekha ji. Very good. Great. Good accuracy along with the speed. Sorry, I'm just verifying the spelling of your name. That's a good name, by the way. Chandralekha. Perfect. Right. So, fatafat se, guys, let's see how we can get this thing. Right, so basically what I know is, I know the area, right, cultivable command area, and out of that I know what is the area for irrigated area for your rice, that I know. Okay, I know the base period also, I know the delta also. If I can get the duty, I have the area, so simply with the help of this that area we can get the answer, right? Let me tell you how. See, so first of all I have got the duty from here. Right, duty will be what? Area by discharge. Right, what is duty? How many hectare of land can be irrigated by continuous supply of 1 meter cube per second of the water? Right, so hectare per meter cube is the duty here. So first of all, let's see, you have to use this equation which goes something like this. Delta is equals to 864 B by D, where 864 you have to use if you want to get the answer in centimeter. If you want to get the answer in meter, then it should be 8.64. Putting all the values here, and let's see what we can get. So I know the base period is given to me as how much? 150, and the delta is given as 130. From here the duty can be determined. Whatever the duty you will get with the help of the area, you can get the discharge also. Let me tell you what is the duty from here. So it is 864 into 150 divided by 130. So yeah, I have got this, and now with the help of area, where is the area? 2500. Cool. So it will be 2.5077. Yep. So area by duty by area when you will do, right? So basically what is area by duty when you will do area by duty. So what is area by duty? It is discharge only. You can see with the help of unit also. Area is what? Area is in hectare, you can say, right? And duty is what? It is hectare per meter cube per second. So here you will see the value will be in meter cube per second. It's the discharge. So discharge is 2.5 cumac, and which says, okay, design discharge is 2.5 cumac. That is correct, because in the question it was given that, where is that? The area to crop, blah, 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 blah. Okay, the design discharge of canal is based on the rice. Okay, that is why I can say it is my final discharge. Cool hai? Bahut hi cool hai. So now the discharge is 2.5 cumac, right? And I know that the delta of the wheat is given to me as 50. Right, and also I know that the base period is 120. With the help of this I can get the duty. Similarly, just now I have got this discharge. I can say duty will be equals to what? Area by discharge, right? This will give me what? This will give me discharge. This will give me duty. So area is how much? Area is you can see how much. Okay, area I have to find out. Duty I have got from this equation. And the discharge is 2.5. From here the area should be 5185 hectare, and that is B option. Very good everybody. Let's see the next question now. Okay, consider the following statement in context to soil water relationship. Answer please everybody, full power ke saath. Let's see whose name will come in this box of fame. Full power ke saath reply guys. Water utilization from the plants is mainly from capillary water. The amount of irrigation water required to meet the evapotranspiration needs of the crop during its full growth duration is its consumptive requirement. The depth of water required to bring the soil moisture level of the given soil up to field capacity is called hygroscopic water. With continuous increase in quantity of water supplied, the yield of most crop increases up to a certain limit and then expected to be constant. Everybody full power, please reply to this question. And if you are enjoying the session, just hit the like button guys. Do not forget to hit the like button and share the video with any one friend of yours. Right, come on guys, answer to this question please. Everybody full power, answer. A, B, C, A, B, C, A, B, C, okay, B, D, okay. Guys, let me rewind everything. This much is the water that you have applied in the field. It has two parts. One part is what? One part is your gravity water. It is not at all getting stored in the soil. So leave it, wastage. Okay, this much of the water is now stored in the soil. It is known as field capacity. It has two parts. One is non-available water, one is available water. Available water is also known as capillary water. Non-available water is also known as hygroscopic water. It is bonded with the soil particle with the help of molecular bonds, and it is bonded with the help of loose chemical bonds, right? So it is not at all available, so we'll just leave it. Now available water is also of two categories, readily available and non-readily available, right? So now water utilization from the plants in the main is mainly from the capillary water. It is correct. Why you are saying it is wrong? It is definitely correct, right? It is definitely correct. Next, the amount of irrigation water required to meet the evapotranspiration need of the crop during its full growth duration is its consumptive use. That is also correct, right? Why it is false? The depth of water required to bring the soil moisture level of the given soil up to field capacity is called hygroscopic water. Hygroscopic water, I have just told you, it is the water which is not available for the growth of the crops. With continuous increase in the quantity of the water supplied, the yield of most of the crop increases. That's true. Up to a certain limit, that's true. And then it is expected to be constant. No, it is not. The yield will decrease. Only A and B are correct. Who gave the answer? Correct answer. Who gave the correct answer? Who gave the correct answer? Let me see. Nobody. Okay. Bhavsya Sagar. Sagar gave the correct answer. Very good, Sagar. Everybody else was saying A, B, C, B, D, D, A, B, D, B, A, B, C, D भी बोल दिया किसी ने तो A, B नहीं यार. What is this? ऐसा नहीं होता. Correct. Anybody have doubt in this? I hope there is no doubt. Okay. Let's move to the next question. Okay. An agricultural land. Again, it is a MSQ question. An agricultural land of 2 hectares is irrigated at the rate of 100 liter per second from an irrigation tank. The duration of irrigation is 6 hours. Okay. It was found that actual delivery at the field is 80 liter per second. which is 2 kilometers from the tank. The runoff loss in the field was estimated as 400 meter cube. Please tell me application efficiency, conveyance efficiency and everything else. Come on, full power ke saath, please reply. Let's see who will give me the first answer again. What actually is application efficiency, guys? You can understand whatever the water we are applying in the field, in the field. So out of that, some water is going in runoff, right? It is not at all used by the crops. So answer please to this question. You have to find the application efficiency and then you have to find out the water conveyance efficiency. Only these two things you have to find out. So please get me the answer and let's see who have got the correct answer. Full power, guys, full power. Please, no laziness here. Please, no laziness here. Yep, correct. That's correct, Madhvi. Correct answer is A and C. Let's see how. Right, let's see how. Cool. So basically here you can see water conveyance efficiency. So how much water is delivered in the field, first of all, divided by water supplied into the canal, right? So you can see how much is going. So you can see from here that agricultural land of 2 hectares is irrigated at the rate of 100 liter per second from irrigation tank. From tank 100 liter is going, right? It was found that actual delivery is 80 liter. So it was supposed to be reached, but only this much was reaching, right? So 80% is the conveyance efficiency. Now let's see how much was entering inside the field, first of all, in meter cube, right? So 80 liter per second was the supply and it was supplied for 6 hours. So for 1 second 80 liter was entering. So for 6 hours you are having this much of the supply, that is 17,28,000 liter, basically 1,728 meter cube. Now out of this, this is what you have applied. Out of this 400 meter cube is running off. So you have to subtract it. Only this much is going inside the soil, right? So water application will be water stored in the root zone, that is 1328 divided by water delivered to the field, that is 1728, and from here you will be getting water application efficiency. So A and C are the correct answer. Anybody have doubt? Perfect. Next question. The culturable, again MSQ question. The culturable command area for a distributary is 2 into 10 to the power 8 meter square. The intensity of irrigation of a crop is 40% if core water depth and core period of the crop are 14 centimeter and 4 weeks respectively. Answer everybody. I think ये क्वेश्चन पहले हो चुके हैं, 2 सी वहां पे हुए थे, मोस्ट एक्सपेक्टेड क्वेश्चन ग्रेड ऑफ सिविल चैंपियन पे. 1-2 क्वेश्चन हैं जो रिपीटेड हैं क्योंकि वो MSQ क्वेश्चन थे, and that happened on your grade of civil champion, not here. I am teaching irrigation here, I think after months. Answer please. Only MSQ question must be, there will be some MSQ question which I have discussed on grade of civil champion, but there are some students who only understand English. So for those, this channel is preferred. So that is why I am repeating those questions. Okay. Come on. But the thing is, if these questions are repeated, then also why your name is not there on the box of fame? That's the question here now. Okay. The only thing is, the students who understand only English, no, they can't join us on grade of civil champion, but I have to tell these questions to each and every student. So that is why only MSQ questions are here. So basically the cultivable command area of distributary is given to us, right? The intensity of irrigation of a crop is 40% if core water depth and core period for the crop are 14 centimeter and 4 weeks respectively. We have to tell the duty and the peak demand. You can see from here, guys, duty can be determined with the help of this, which goes something like this. Duty is 864 into base period by delta. Cool hai? Right. So 864, base period is given as 28, right? And delta is given as 14. Sahi hai. 4 weeks and 14 it is given. Cool. So from here what I am getting, guys, 1728 hectare per cubic. So duty is what? Area by discharge, right? From here area can be determined. Area will be how much? Whatever the intensity of irrigation you have into the cultivable command area, right? So intensity of irrigation was how much? 40% only. So 40% of 2 into 10 to the power 8 is being irrigated, right? Is cultivable command area, and here you will be having what? Divide by 10,000 hectare, whatever the area we will be having, and from here you are getting what? You are getting the value of your area, right? Now you have the area, you know that discharge is equals to area by duty. You have the duty, you have the area, you can get the discharge. Everybody, that's 4.63, and yep, answer is discharge is 4.63 and that is 1728. So B and C are the correct answer. क्वेश्चन रिपीटेड है, फिर भी आंसर किसी का सही नहीं आया. ये भी ठीक है. ए भी कैसे बोल सकते हो यार? हाउ यू कैन से ए एंड बी आर करेक्ट? हाउ यू कैन से ए एंड बी आर करेक्ट? फर्स्ट ऑफ ऑल प्लीज टेल मी दैट. ड्यूटी ऑफ क्रॉप इज दिस, ड्यूटी ऑफ क्रॉप इज दिस. This is the next level of making mistakes. Set है. Next question. Again MSQ. A certain crop is grown in an area of 3000 hectare which is fed by a canal system. The data pertaining to this irrigation are as follows. Field capacity is given to us as 26%. Optimum moisture content. Okay. Optimum moisture content is 12%. Permanent wilting point is 10%. Effective depth of root zone is 80 centimeter. Apparent relative density of soil is 1.4. If the frequency of irrigation is 10 days and the overall irrigation efficiency is 22%, then which of the following statement is or are correct? Daily consumptive use is 1.746 centimeter. Discharge required for irrigation is 21.38 meter cube per second, or what? Answer, please. Prayag, what happened? Your answer is deleted. Why? Did you remove it? Answer please, everybody, try. Please try this question and get me the answer. Daily consumptive use and the discharge you have to find here. Daily consumptive use and the discharge you have to find in this question. Can we do that? Very good. Let's see if you are having it, if you are getting the correct answer. Okay. Yep, yes, that's correct. Chandralekha. Correct. C and D are the correct answer. Let's see how. So here C and D are the correct answer. Let's see how. Okay. So guys, I have discussed this thing in my lectures also. If you don't know this concept, you can watch any session of mine. It is available on YouTube also. There I have told you about field capacity and optimum moisture content, right? So you know this, how to get the depth of the water, right? So from here you will be getting the depth of the water as 15.68 centimeter. Cool. Daily consumptive use will be how much? It will be, guys, if this is the requirement, and how many days we have? 10 days, right? So daily will be how much? It will be 1.568. Since I have written daily consumptive use, I don't have to write per day. I don't have to write per day because it is already said daily consumptive. Total irrigation water required, that is loss in field and conveyance losses, okay, and conveyance. Cool. So here, guys, it was given that we have 22% overall efficiency, right? So if this much of water I will supply, most of it will be wasted, right? I have to take care of this. So I am increasing my requirement and it will be 7.127 by keeping 22% efficiency in mind, right? So now if I will provide 7.127, out of that 1.568 will be provided to my crop, which is being required. So field area is how much? 3000 hectare, which is 3000 into 10 is about 4 meter square. So discharge required will be how much, guys? Discharge you can get with the help of this, since 7.127 is required, right, per day. Cool, per day. And area is how much? 3000, right? So from there, and day will be converted in seconds, so you will be getting it as 24.75 meter cube per second. Set hai? Very good. Your revisions and most specific question was recently studied, so able to answer. That's good. That's great. That's great. Next question. The moisture holding capacity of the soil is a 80 hectare farm is 16 centimeter per meter. The field is to be irrigated when 50% of available moisture in the root zone is depleted. The irrigation water is to be supplied by a pump working for 8 hours a day, and water application efficiency is 80%. If the root zone depth of crop is 1 meter and the consumptive use is 4 mm per day, then capacity of irrigation system required to irrigate the crop in 40 hectare is how much? Solve this now. Take your time starts now, and let's see who will give me the first answer. And let's see who will give me the first answer to this question. Moisture holding capacity of the soil in a 80 hectare farm is given to us as 16 centimeter per meter, and field to be irrigated when 50% of the available moisture in the root zone will be depleted. Try. Please, fatafat say. How much they are saying? So basically they are saying 16, right? So when you will be having 8 centimeter, then you have to use it, right? 8 centimeter jab hoga, tab you have to apply the water. 8 centimeter means 80 mm basically. So frequency of irrigation can you get if you have the consumptive use? Can you tell me the frequency of the irrigation, guys? That is not at all tough, I suppose, right? If you know that 80 mm irrigation water is being required, right? And I know the requirement is 4 mm per day. Can I get number of days, frequency of irrigation? Water delivered to the farm, you have to just consider the efficiency there. Total volume of the applied water you can get, discharge capacity you can get from there. Come on, answer. And guys, if you are really learning something new from this session, do not forget to hit the like button. It is a mandatory thing now. Answer. Yes, Kaushik, very good. That is frequency of irrigation, what you have just gave me. Final answer is what? Okay, now let me tell you guys, or should I wait? Let's see if any one name can come in the box of fame, then we'll move forward. Okay, let's move ahead then. Okay, so irrigation is done when available moisture reached out to be 50% of the available one, right? Which means 8 centimeter. It means 80 mm basically, right? So frequency of irrigation will be what? 80 by the consumptive use. It was given to us 4 mm per day, right? So 80 mm by 4 mm per day, it gives us the frequency of irrigation as 20 days. Okay. Now next is water delivered to the farm. So you can clearly see here 80% is the efficiency. So how much I have to apply? I have to apply 10 centimeter, right? I have to apply 10 centimeter. Cool hai? बहुत ही cool hai, right? Instead of 8 centimeter, I will apply 10 centimeter, so that 2 centimeter will be in the loss, right? And rest amount will be provided. Then what is the total volume of applied water, guys? It will be 10 into 10 to the power minus 2, just to convert it in meter, and 40 into 10 to the power 4, because it was the area, I think, right? It was the area, 40 hectare, right? Yep. So 40 hectare was the area. So total volume of the applied water is how much? 40,000 meter cube. Now the discharge capacity will be volume applied by frequency of irrigation. That is the discharge capacity basically, meter cube per second. From here you will be getting 23.1 liter per second. And now we know that for 8 hours per day it is running. Okay, so discharge capacity will be how much, guys? 23.1 for 8 hours per day it is running, right? And from there you will be getting your answer as 69.3. Set a new type of question, I suppose, right? This PDF will be available to you on the Telegram group. If you want the PDF, you have to join the Telegram group, which is then the description link, description box mein you have the link. Kindly join. Next question. In a canal irrigation project, 62% of the cultivable command area remained without water during Kharif season, and 73% of cultivable command area remained without water during Rabi season in a particular year. Rest of the area got irrigated in each crop respectively. What is the intensity of irrigation for the project in the year? Answer. A little bit different question. What is the intensity of irrigation for the project in the year? Basically, you are given what? 62% of cultivable command area remained without water. So basically you are having the area which was not irrigated out of cultivable command area, out of CCA, the area which was not irrigated, that is given to you. So in Kharif season it is 62%, in Rabi season it is 73%. Answer. Give your best, try karo. Try. Without try, nothing can be happened. Try, please. Hi sir, I'm getting 112 marks on. Hey Alvin, how are you? Can I prepare for mains? 112. That's, I think, at the border only, right? You should go for mains, obviously. Because if you are going for mains, then also you are preparing for civil engineering only. So there's no harm, right? पढ़ाई कभी waste नहीं जाती. So some are saying 135, some are saying 65%. Let's see. Okay. So let's see how to do this. So Kharif season is 62% cultivable command area not irrigated. Rabi 73% not irrigated. So what is the intensity of irrigation? Total area irrigated in both the seasons of the cropping, right? What is the total area which was irrigated in both the seasons of cropping? So 100 minus 62, basically, right? It was irrigated, cool. And 100 minus 73, it was irrigated. So total it was 65%. So total 65% of the area is irrigated. So 65% is the correct answer. Very good, Amit. Next question. An identified source of irrigation water has ion concentration of sodium, calcium and magnesium as 22, 12 and 7 milliequivalent per liter respectively. The SAR, sodium absorption rate of this water is how much? Answer quickly. Very easy and cheesy question. It is try by yourself. Come on, and let's see if we can hit 50 likes. Let's see if we can hit 50 likes before 5 p.m. Everybody, if you haven't liked the video yet, kindly just hit the like button and answer this question now. An identified source of irrigation water has ion concentration of sodium, calcium, magnesium as 22, 12 and 7 milliequivalent per liter respectively. The SAR of this water is how much? Come on, answer. How much? 7.13. 7.13. Okay. 7.14. Cool. Let's see. So yep, 7.14 is the correct answer. Sodium absorption rate is nothing. The sodium ions under root by calcium plus magnesium by 2. Cool hai? So sodium was 22, calcium was 12 and magnesium was 7, right? So it will be 22 divided by under root 12 plus 7 by 2, that's 7.14. Set hai. Next question. Moisture holding capacity of soil is 80. This is the same question, right? This is the same question, right? Yes, it is the same question. Sorry. Next question. The field capacity of soil is 22%. Its permanent wilting point is 13% and specific dry unit weight is 1.4. If the depth root zone of crop is 70%, 70 centimeter, the storage capacity of the soil is how much? Come on guys, answer. Come on guys, answer. And I know you can get me the answer, so I'll be writing your name in this box of fame. Everybody, let's see whose name will appear in this box of fame this time. Come on, with full power, get me the answer. Field capacity of the soil is given, permanent wilting point is given, specific dry unit weight is given, that depth root zone of the crop is 70 centimeter. The storage capacity of the soil is how much? C. Perfect. So yep, it is C. Okay, so yeah, water storage capacity will be how much? So the depth of water is D into GM into field capacity minus permanent wilting point. That's 1.4, right? It is given as 70 and this. So yep, 8.82 is the right answer. It was easy question though. The depth of penetration of water along the length of the 45 meter of the border strip are observed. The observed values are 2, 1.85, 1.93, 1.55, 1.45 and 1.2. What is the water distribution efficiency? Answer. Answer please. This is the ground surface. Okay, and the water is distributed something like this. Cool. So how much it is? 2, and this is 1.2. 1, 2, 3, 4. 4 lines I'll be needing here. So 1, 2, 3, 4. Cool. It is 1.85. It is 1.93. It is 1.55. It is 1.45 meter. Say yeah. Get me the answer, guys, now. This is how the water is distributed. So now the answer. First of all, get the average value of all this. So the average will be how much? It will be 2 plus 1.85 plus 1.93 plus 1.55 plus 1.45 plus 1.2. Set hai, divide by 1, 2, 3, 4, 5, 6, divide by 6. So let's see here. So it is how much? 0.26. It has done the same thing. 0.34, 0.927, right? क्या किया ये? 3, 4. Okay. Here it is. D value 2, 1.85, 1.93, 1.55, 1.45, 1.2 का 6 किया. It is 1.66 meter. Correct. Now the magnitude of deviation. You have to see how much we are deviating from the average value. Average value is 1.66. Cool. So it is somewhere here, right? So you have to see these depths are deviating from the average value by how much amount. You can see from here 2 minus 1.6 itna, and you have to take the average of all these. So the average of all these is 0.226. So 1 minus d by d into 100 will give you the distribution efficiency. It is how much? 1 minus 0.26 by 1.66, and it is 84.33%, which is option C. Next question. A canal has a flow rate of 4.5 cubic and has medium silt size silt with an average grain size of 0.016 centimeter. What will be the velocity through the canal as per Lacey's theory? Please answer. Please answer, everybody. And take the session like to 50. Hit the like button if you haven't liked it yet. If you are enjoying the session, then only like the video. A canal has a flow rate of 4.5 cubic and has medium size silt with an average grain size of 0.016 centimeter. What will be the velocity through the canal as per Lacey's theory? C, B, let's see. So silt factor is how much? It is 1.76 into D. D is the average dia of the particle, silt particle, and that too in mm, right? That too in mm. So how much it should be? It is 0.016 centimeter, right? So it will be how much? It will be 1.76 under root 0. How much is this? 0.0, right? It will be 0.16. 0.704 it is coming. 0.0. So okay, wait. I think here it must be wrong. It must be wrong here then. I have to put the value of D in mm only. Okay, please remember this one thing. No problem. I'll just change it here. It's wrong. 0.0016 mm. Now it is fine. Now it is fine. Now do it. Right. Now you will be getting F value as 0.0704 because this D we have to put in mm only, right? Discharge is 4.5, F is 0.0704 whole square by 140 raised to the power 1 by 6, and from here the answer is 0.233. 0.233 is C. Sahi? Correct? Very good. Next. The slope of regime channel in designed using Lacey's theory. Okay. If the average size of bed material is 0.8 mm, the velocity of flow is 0.944 meter per second, then which of the following statement are correct? Again, this is a MSQ question. Please solve. Again, this is a MSQ question. Please solve, everybody. I'm asking you to like the video and somebody is disliking the video. Why? Answer, everyone. Hmm. 0.16, I am not 0.016. Yes sir, I have changed the question. I can do that. It in the question it is given as 0.0016. Now it's fine. Answer guys. The slope of regime channel is designed using Lacey's theory. If the average size of the bed material is 0.8 mm and the velocity of flow is 0.944 meter per second, you have to tell what is the silt factor, discharge through the channel, bed slope, wetted parameter. Let's see if you can get the correct answer. Everybody, let's see if we can get the correct answer. Rishabh is saying A and B. Is it A and B only? Let's see if Rishabh is correct or not. Let's see if Rishabh is correct or not. He is saying A and B. A and B. A and B. A, B, D. Sonu ji is saying A, B, D. Okay. Madhvi is saying A, B, D. Okay. So Rishabh, would you like to change your answer, or you are confident enough that the answer is A and B only? Jayesh is also saying A, B, D. Atul is also saying A, B, D. Abhay is also saying A, B, D. Answer is A, B, D only. A, B, D. Right. Let's see how. Silt factor I have just told you how much it is. It is 0.8 and 1.574. Velocity of the flow you can get the same just now we have did, right? And if you want you can get the discharge from here. Velocity I have, so the discharge is 40 meter cube per second. Parameter can be determined as per the Lacey's theory, 4.75 under root q. I have the discharge as 40. From here parameter is coming this much, and this is the last equation of slope. This I have told you, I think, right? So it is how much? F raised to the power 5 by 3 into 3340 divided by 3340, q 1 by 6. So from here the answer is 1 by 2900. Instead of 2400, 2900 should be the slope. 1 in 2900. Very good, Amit. Very good. So A, B and D are correct. Next question. Select the correct statement regarding theory of seepage. Regarding theory of seepage, please get me the answer. According to Bly, percolating water flow follows outline of the base of the foundation. According to Lane's creep theory, horizontal creep is less effective in reducing the uplift or causing loss of head than vertical. According to Lane's creep theory, vertical creep is less effective. According to Lane's creep theory, vertical creep is equally effective in reducing the uplift or causing the loss of head that of horizontal creep. Answer everybody. Answer everybody. Let's see if we can get the correct answer to this question also. No, obviously, right? MSQ. Yes, this is MSQ. This is the MSQ. That was MSQ, guys. This question is MSQ only. जयेश, बेटा पढ़ाया था उस वाली सेशन में, आपको सिविल चैंपियन पे बताया हुआ है मैंने क्लास में. आप कैसे गलत कर सकते हो? बिल्कुल सही है. सो यप, एज पर द ब्लाई theory, percolating water follow the outline of the base of the foundation. That is true. Next, according to Lane's creep theory, horizontal creep is less. What is the weightage that he has given to the horizontal creep, guys? What is the weightage that he has given to the horizontal creep? Everybody please tell me in the comment box. What was the weightage he has given to the horizontal creep? 1 by 3. Okay. Yep, it is wrong. Next. MSQ again. Answer. Is it MSQ? I think it is not MSQ. Okay, let's see. So guys, a regime channel will have side slope of value 0.5 horizontal and 1 vertical. Okay, this is what they are saying. Next is Manning coefficient is calculated by Stickler's formula. The wetted parameter increase with increase in design discharge. Hydraulic radius decreases with increase in silt factor. Let's see if you can answer. Everybody, as per Lacey's theory, Lacey's method for design of alluvial channels, identify the correct statement, everyone. हर्ष मत कर यार, please. Request करूँगा. Whatever you want to write, just write it once. Just a request. All correct? Okay. A, B, C, D. A, B, D. Come on guys, try. Let's see if you can get it. Let's see guys if you can get it. स्टिकलर फॉर्मूला सर आपको क्लास में पढ़ाया गया होगा, अगर आपने पढ़ाया कहीं से तो थ्योरी. Answer everyone. Okay, brilliant. Actually all are correct, that is true. So yep, regime channel will have this much, it is correct. Manning's coefficient is correct. Weighted parameter increase in the design discharge, and yes, hydraulic radius decreases with increase in the silt factor. Dekh lo, you can see from here also all the relations. Hydraulic radius decrease with the increase in silt factor, right? It is being given here. Then P is equals to 4.75 discharge. So weighted parameter increases with increase in design discharge. That is also true. Channel side slope was assumed to be 0.5 by 1 horizontal. Correct? Correct. This was also being told. Right? A regime channel will have side slope of value 0.5 horizontal by 1 vertical. Next. Calculate the safe length of sheet pile in meters provided below the bed of the river in alluvial soil using Lacey's scour depth. Given discharge per unit width, that is the small q, is 2.8 meters square per second, and the silt factor is given to us as 1.3. Kindly please get me the answer, everyone. Calculate the safe length, guys, quickly. It is my kind request to everyone, please, whatever you want to write, just write it. You know, if you want to say A, just say A. If you want to say B, just write B. If you want to say C, just type C. If you want to say D, just type D. Don't write A, B, 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 C, 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 D, 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 D. Otherwise, you will be blocked automatically. Answer. Okay, Rishabh. Let's see if you have got the correct answer or not. So Rishabh, this is what? This is the depth of sheet pile. Have you are you considering the factor of safety also, everyone? Are you considering the factor of safety also? No, you are not, right? So Lacey's scour depth formula is very simple. You know, there's the small q and the silt factor, and from there you will be getting the Lacey's scour depth. Direct empirical formula. There is nothing to tell about this. For additional safety of sheet pile depth, we consider the depth as 1.5 times the R. So depth of sheet pile will be 1.5 times of this, that is 3.7 meter. Okay, 3.7 meter. Please don't make these mistakes. Next. All right. So which of the following statement is or are correct with respect to lined canal? So lined canal are designed based on Kennedy theory. Lined canal are designed based on Lacey's theory. The design is based on Manning's equation. The design is based on Chazy's equation. Everybody kindly please try and get me the answer. Everybody please try and get me the answer. Come on guys, if you haven't liked the video and you are learning something new from this session, kindly just hit the like button right now. And let's see if we can reach to 50 likes by 5 PM. Can we? Answer A, B. Okay. Answer everybody. Come on. Hello. Who's this? Rashmi. Answer please. 2. No. The design of lined canal is based on the Manning's equation, not on in your Lacey's theory only, right? It is based on the Manning's equation. They are both the theories are for alluvial canal, guys. Kennedy and Lacey, they are true for unlined canal, or you can say alluvial canal. Next. A regime channel carries a discharge of 130 cubic by Lacey's theory. If side slope is 1:1 and the average size of bed matrix is 1.2 mm, then assume channel is trapezoidal shape. Then, okay, this is MSQ again. Answer. Answer everybody. Answer everybody. 50 likes. Perfect. Thank you so much. Answer please, guys. A regime channel carries discharge is given to us, side slope is given to us, bed mix size, basically silt particle size is also given to us, then channel is also trapezoidal. They are saying you have to tell the silt factor, the velocity, the area, the parameter. Let's see if we can get the correct answer. Come on. Guys, it is a MSQ question. I'm again repeating. ये एक MSQ question है. It is an MSQ question. Please try. A regime channel carries discharge of this much. Okay, I'm telling you the answer now. See. So I have the size in mm as 0.12, isn't it? 1.2, right? 1.2. Next, from here the silt factor is 1.93, right? So this is correct. Next, from the same equation which we are using again and again, velocity is 1.2 meter per second. So this is wrong. Next, area is discharged by velocity, that's 105.7. So this is correct. Then parameter is 4.75 under root q, that's 54.2. D, correct. Right? So A, B, D is the right answer. Next question. The concentration of sodium, calcium and magnesium are given to us. This, okay. The electrical conductivity is 200 micromoles per centimeter at 25 degrees Celsius. Now what is the SAR and what is the type of this water? Answer. Answer everybody. Everybody answer please. All right. So SAR is coming as 14 and from 10 to 18 it is S2 category, right? And from 100 to 250 of micromoles per centimeter it is C1 electrical as per the electrical conductivity, right? So the answer should be 14 and C1 S2. 14 and C1 S2. A and C. Next question. Okay, an area of 0.04 hectare is irrigated with the help of tube well with discharge through supply ditch 0.02 cubic per second. Okay, so cubic basically, right? If F is 15, so basically if infiltration rate is given to us as 15 centimeter per hour and the average depth is given to us as 17 centimeter, then time required and maximum area that can be irrigated will be how much? So basically we have to tell how much time it will be required to irrigate this land. Also we have to tell what will be the maximum area that can be irrigated. Here you have to use this one equation which is very important to understand, and that's this one, right? Which goes something like this: T is equals to 2.303 Y by F, where Y is the average depth of in the field of the water, Y is the infiltration rate, right? Q is the discharge here. You have to keep track of the units. Whatever the units you are putting, they should be same. Okay. So area, how to get the area? So area will be discharged by whatever the infiltration rate we have. So discharge is how much? 0. Where is it? कहाँ पे दिया है? 0.03 लिखा है another. Wait, it should be 0.3 here. Typing mistake, sorry. 0.03. Okay, that's a typing mistake. So from here you will be getting discharge is 0.03 divided by whatever the infiltration rate we have, 15 centimeter per hour. So first of all we have converted it into meter, right? And then we have converted it R into seconds. Now from here area is 720 meter square. So area is 720 meter square. That is correct. Next, from here you have to put all the values. 2.303. It was 17 centimeter. Now I have converted in meter, right? And this was 15 centimeter per hour. So now it is in 15 meter per second. Here also you have to convert accordingly, and the value of t will come in seconds, and that is 3319.406 seconds, which is 55.32 minutes. So D is the correct answer. B and D are the right answer. Next question. Following data were obtained from the stability analysis of a concrete dam. Total overturning moment about toe is 3 into 10 raised to the power 10 meter. Okay. Total resisting moment about toe is 4 into 10 raised to the power 5 ton meter. Total downward weight of the dam is 6,000 tons. Total uplift force is 1,000 tons. Base width of the dam is 50 meter. Calculate the maximum and minimum pressure on the soil. Answer. Everybody, this is from your gravity dam chapter, so please give me the correct answer quickly. Everybody, full power answer. Take your time. Take your time. Give me the answer. B. Okay. Let's see. So basically we have to find out this thing, right? P max or minimum is your summation of all the vertical forces by width of the dam 1 plus 6E by B. E is the eccentricity, right? So for this we have to find out this E. Right, E is what? Base by 2 minus D. What is D? D is your ratio of the this momentum, summation of moments, right? Algebraic sum of the moments, and aapka whatever the vertical forces we are having. Cool. So resisting moment minus overturning moment will give you the summation as 1 into 10 raised to the power 5. Then here guys, this moment, summation of moments and summation of vertical forces are coming as 20 meter. From here you can get the value of E as 50 by 2 by minus 20, that's 5 meter. P max you will be finding from here, it is plus minus, so right, plus value will be 160 ton per meter square and minus value will be 40 ton per meter square. So 160 and 40 ton meter per meter square is the answer. C is the right answer. Next. Okay, a gravity dam has upstream water depth of 75 meter and tail water depth of 7 meter as shown in the figure. To relieve the uplift pressure, a drainage gallery has been provided in the dam. The center line of the drainage gallery is 8 meter away from the heel of the dam. What will be the uplift pressure on the center line plane of the drainage gallery in kilonewton per meter square? Answer everybody, full power. Answer 291. Okay, so we have to find out this ordinate. So it is how much? It is gamma W H plus 1 by 3 gamma W capital H minus H. This is the height of water in the downstream and it is the height of water in the upstream end, right? So in the downstream it is 7, in the upstream it is 75. From here it is 29.03 kilonewton per meter square. Tell me this question now. For the elementary profile of gravity dam, the height of the water level from the base is 20 meter. Assuming the unit weight of water as 10 kilonewton per meter cube and the unit weight of concrete as 24 kilonewton per meter cube, assume uplift to have developed fully. Which of the following statement are true? base width is this much, uplift force per unit length is 417. Answer to me guys, full power, answer to me. Answer. Okay, let's see. So guys, for no tension at the base, we know that base width will be h under root g minus c. Set है, set है. Please answer. Okay, so from here you will be getting the value as how much? 16.90, right? Right. Right, okay, and as per your uplift, for how much uplift we will be having, you can see half gamma w b h, right, and that is how much? 1690 kilonewton per meter. Next question. An elementary triangular concrete gravity dam is designed to support 80 meter of reservoir height and full uplift. The required minimum base width ignoring uplift is how much? Ignoring uplift. Ignoring uplift. Answer, everybody, full power. One 2.68. Let's see. Okay, so when resultant of all forces passing through outmost middle third, basically it should be B. The same thing which I have just told you, right, for no tension. But here C we don't have to consider, right? It has been given that we have to ignore it. So it is 80 under root 2.4. So from here it is 51.64, right? And as per the sliding criteria, the BYJU'S value is this much. We have to choose the greater value of these two. Now quickly, please tell me, everybody, out of these questions, how much percentage of questions you were able to make? Out of all the questions, how much percentage of questions you were able to make? Quickly, please respond. Quickly, please respond and tell me. How much percentage of questions you were able to make in this particular session? Percentage you have to tell me. So if you are getting guys 75% or above, then you are in a very good position here. And if you are getting 60 to 75%, you have to again revise the subject one more time. If you are getting less than 60% in this test, then guys, you have to give it a special attention, and that's it. Okay. Perfect. सही है, सेट है सीन, बहुत ही सही है. ओके, cool. This is the last question and let's close the session then. Which of the following statement is correct? You have to tell me. Out of A and B, A is correct, B is correct, both are correct, or none of them. Answer. D. That's correct. They are reversed basically. None of them are correct. This is for this and this is for this. Cool. Perfect. So guys, thank you so much. I hope you have learned something from this session. I hope you are getting things here, whatever I have discussed, you don't have any doubt, right? So this completes your series of mock gate test of every subject, whatever I and Abhinav sir have discussed here, right? So this is it. I hope you all have enjoyed this series and you have learned something new from this series, right? So how many stars you would like to give to this complete series of mock gate test which was taken by Abhinav sir and me? You can please let me know in the comment box with full power. Perfect. All right. So we'll get you again, right, with another series. Till then, you just have to take care of yourself, right? Take care of your family. Yes, please just study the gravity dam. It is an important part. It is not at all, you can't skip it if you are studying irrigation engineering. Okay. So thank you so much, guys. I hope this series has helped you in. If it has helped you in any manner, then I'm glad. Thank you so much, everybody, for joining the series, and always stay here, right? So I'll see you again with something new, right, which will help you in your preparation. Till then, just prep smart, stay safe, go Gradeup. Thank you so much, everybody. I'll see you soon. You can connect with me through this Telegram group which is there in the description box, and you will get all the PDF and everything there only. Okay, thank you so much, everybody. Take care. I'll see you in the Minty War today, by the way.